talking about using geometric mean to find missing sides in triangles. As you guys noticed on the last question from that activity that we just did, they said that geometric mean was A over X equals X over B, right? So basically another proportion, what we did in the last unit. So the first thing that we're actually going to do is just define what geometric mean is, okay? This is for any two positive numbers the geometric mean is the number x such that the following is true. That proportion that was in the activity that we talked about. So A over X is equal to X over B, where X is the piece that we're looking for. Okay? So something you may need to make note of here, if I cross multiply, A times B is going to be some real positive numbers, right? So it's going to be two positive numbers. But when I multiply this direction, I'm multiplying x times x. Well, what is x times x? X squared. So I'm going to end up with x squared equals a number. And I'm just looking for x. So if I have x squared equals a number, what would be my next step in solving for x? To take the square root, right? So you may want to make a little note of that here, that geometric mean is the square root of the product of the two numbers. Okay. So now that we know what geometric mean is, we kind of talked about how we would actually solve it. You guys said in the end we end up taking the square roots. Let's look at doing an actual example of this. It says to find the geometric mean of 5 and 20. So the two real positive numbers are 5 and 20. We're solving for x. So basically that makes these your A and B, and you're just going to substitute that in to the proportion that we have written up above. So in place of A, I'll have 5 over x is equal to x over, in place of B, we have 20. And as we practiced in previous units, whenever you're solving a proportion, all you do is cross multiply, right? So when I multiply this direction, I've got x times x, which you guys said gives us, good. And when I multiply this direction, I've got 5 times 20, which is 100. All right, and then what did you guys say we need to do to find x? Square root. So what is x here? Good. All right, I want you guys to do the next two examples, and we'll check our answers together here in just a moment. So go ahead and do examples 2 and 3 of finding the geometric mean. Okay. On the second example, what did we set up as our proportion? Good. And when we cross multiplied, what did we get? Right? And therefore, x was very good. Okay. On the third example, what was our proportion? Good. We cross multiplied and ended up with very good. Therefore, x was square root of 55, right? So since there is no perfect square root and it can't be simplified, right, we can multiply 5 times 11, but neither one of those have square roots. Good job. Okay, so we have this right triangle similarity theorem. And it's pretty much exactly what you guys discovered in our activity. Okay, so this theorem says that the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar. To the original triangle and to each other. So whenever we draw in that altitude, it's going to split it into three similar triangles. The big one that it originally was, and then once you draw in the altitude, it splits that one into two more, and all three of those are similar. So in the triangle DAB, which is the triangle that we originally started with, when you draw in that altitude AE, we end up with all of these different similar triangles. So triangle DEA, which is the small one here, is similar to triangle AEB, which is the middle-sized one. And that same small one, DEA, is also similar to the really big one, DAB. And the really big one and the medium-sized one are also similar. So AEB is similar to DAB, which is exactly what you guys told me in that activity. They all end up similar, and therefore meaning they've got those congruent angles, which you guys talked about, as well as the sides being proportional. Very good. So, in summary, for this page, geometric mean is the square root of the product of two numbers, and that altitude is going to divide your triangle into three similar triangles. Okay? All right, so if you'll flip it over onto the back, we're going to talk about two different corollaries. A corollary is kind of like a theorem or a postulate. It's basically just a small rule that we can use to help us solve. Okay? So the first corollary is sometimes referred to as heartbeat. It gets its name from how it looks in the picture. Okay? So this occurs when an altitude is drawn to the hypotenuse of a right triangle the length of the altitude is the geometric mean between the segments of the hypotenuse. Okay? So in other words, what they're saying is that the x is your altitude. So in geometric mean, remember we had a number over x equals x over a number. X is your altitude, okay? So this part right here, my altitude, this is what would be x in that geometric mean. Your A and B are where this gets its name, heartbeat, So whenever you see like a heartbeat on like a monitor, you know, it looks just like this, right? Over, up, down, over. Okay, that's exactly where this gets its name. This part from A to N, this is going to be your A, however long that piece is. And then it goes up the altitude, back down the altitude, and this is your B. And remember, geometric mean is A over X. You come back down X over B. So you'll have this portion, however long it is, over X equals X over B.
Wait, so is B just into B?
Mm-hmm. So if you were to, in that specific example, write out what exactly that is, so it's from A to N is your A over our altitude, which is NC or CN, is equal to itself, NC or CN, however you want to name it, over this portion here, NB. Okay. So here they give us a triangle that actually has numbers in those places. So I'm going to draw in what the heartbeat would look like. So it's here, up, down, and over. So in this triangle, what's my A? 4, good. Over, put it over X, right, is equal to X over what? 25, very good. And then we would just cross multiply and solve like we did on the front. So I've got X times X, which gives us, right, and 4 times 25, which is, so X is, very good. Okay. All right, the second type we can have is what we call rabbit. This one is the same thing, but in this case, it's when each leg is part of the geometric mean. So when altitude is drawn to the hypotenuse, of a right triangle, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse. That is adjacent to the leg. Okay? So adjacent just means beside. So in this scenario, it could be on either side. It could be for this side, or it could be for this side. So if we were talking about the left side, this would be BA over AC is equal to CA over AN. Or it also could be for this side, and that one would be AB over BC is equal to CB over BN. So, in this figure here, we're not actually going to solve it, just set it up. If I was using this one here, this would be from BA, which was the entire bottom. That's what's the entire bottom of this piece? 29 over X equals X over. So it said this was X and this is X, right? We come back down the same piece. Over it says AN, which is this portion here. And how long is AN? 4. Okay? And it's supposed to kind of look like rabbit ears when you draw it out. That one's not quite as clear to me as the heartbeat, but it's a way to help remember how to set it up. Okay? Or Alternatively, if you did this one, that's when you're looking over here at the right side. So it's still the entire bottom, which is still 29, over x, which is your leg over here, is equal to x, that same leg, you come back down, over this smaller portion here, which is how long? 25. And then just like the others, you cross multiply and solve. Okay? All right. So, whenever you are looking for the altitude, which line is the altitude? Right, the one that's down in the middle. So if that's the piece you're looking for, you're going to use heartbeat, which was the one towards the top, right? But if you are looking for one of these outside pieces, here or here, that's when you're going to use the outside leg or hypotenuse, which is corollary number 2, sometimes referred to as the rabbit. Okay? All right, so we're going to do further practice of this tomorrow, but for today, just so that everyone does practice one on their own, I'm going to hand you this little exit ticket for you to just stick in the box before you leave. The first one is just a geometric mean. It's already set up for you. The second one, you're solving for x. X is the altitude, so you'll need to set up something that looks like this and solve it, okay? So you've still got about 5 minutes to do these 2 questions, and you just need to make sure you finish them before you leave, and then stick it in the box. Did everybody get one? Yeah.